Here's more SOHCAHTOA practice. So we're given 3, 4, or 5 right triangles, so we have the 3 sides. We want to get the angles. So there's different ways to set this up. We can do sine of x is opposite over hypotenuse, SOHCAHTOA. So that's opposite over hypotenuse, 3 over 5. That reduces to 0.6 if you want. And you take the inverse sine of 0.6, and you get about 36.86. And this is just short of checking your work. If you do the sine of 36.86, you should come out to 0.6, and so you can check that with your calculator. All right, getting x again with cosine, adjacent over hypotenuse, CAH. So take the inverse cosine of 0.8, 36.86 degrees again, of course, should be, same triangle. One more time, tan x, tan is opposite over adjacent, so inverse tan of 3/4, which is 0.75. So that's just trying out the different ratios. If you want to get the remaining angle, yes, you can subtract from 180. So 180 minus 90 minus 36.86. All right, 8, 15, 17 right triangle. Sine of q is opposite over hypotenuse, so 15 over 17. Take the inverse sine. To get r, subtract from angles from 180. Easiest way to go. 9, 40, 41. If you want to get the cosine, get q, we can try cosine. Adjacent over hypotenuse, 9 over 41. So take the inverse cosine. So this is all situations where you've got to use inverse trig functions because you're not given the angles, you're given the side lengths. So here's another example. You can pause it if it's too fast if you want to take a longer look at it. And one more. This tight. Another one. Okay, in this case now we have 2 sides. To solve a triangle means find all the angles, all the sides. The only difference here is we don't have the last side. So if we want to get the angle r, we have 2 sides so far, opposite and adjacent, so we'll use tangent. That's how you decide which trig function to use, is what do you have. So then inverse tan gives us about 36.86. Get the last angle. Pythagorean theorem is one way to get the last side. And of course we'd get rid of the negative answer. Skip this one, same problem, different numbers. Now in this case we have one of the acute angles, so it's going to be a little different now. We have one of the angles rather than trying to get an angle. So the way to think about this is, all right, if we want to get, say I, we say, all right, we know the hypotenuse, we don't know the adjacent, so that goes with cosine. So we have adjacent over hypotenuse. Multiply the 30 to both sides, so I is 30 cosine of 35, which is approximately 24.57. Now at this point you've got 2 sides. You could use the Pythagorean theorem, but instead we'll use some more trig. U is the opposite side compared to this angle. 30 is still our hypotenuse, so opposite over hypotenuse is sine. That's why we chose sine. Opposite over hypotenuse. Multiply both sides by 30 again. And you've got yourself 17.2. This is just getting the last angle by subtracting, again, from 180. Another example, we're getting u, so u's an adjacent side compared to our acute angle. 45 is the hypotenuse, so cosine 55 is u over 45. And then to get k, let's see. Actually, we have k, excuse me, but the sine is the opposite, so that's I over 45. Opposite over hypotenuse, I over 45. Multiply both sides by 45, and then to get the last angle, again, we'll subtract from 180. This is a 30, 60, 90, so you could do this without trigonometry. The idea here, though, is that you have the variable in the denominator, and so you could flip these two, as I've mentioned, so you end up getting I is 9 over tan 30, and they show it a couple more steps. So I is 9 over tan 30, and that comes out to about 15.58. Now, Pythagorean theorem to get the last side. The idea is just to show you different ways to get the same information. So it comes out to 18, which makes sense because if 9 is opposite the 30, to go from the 30 to the 90 side, you double it. And so 9 to 18, you're doubling. All right. This time, if we want to get I, 6 is an opposite, which we know. I is an adjacent, so we'll use tangent. So tan 36 is 6 over I. Again, you can just flip these two guys. So I is going to be 6 over tan 36. And there you see it. which comes out to approximately 8.26. So now if we want to get the last side, we can use Pythagorean theorem, or we can do more trig. And it's around 10.2. And to get that last angle, subtract from 180. It's an easy way to go. This is a 90-degree angle. Again, of course it is. This time we have two sides. So because we don't have the angles, we have to use an inverse trig function. So this is like the examples we showed earlier. So that's a pretty good rundown of right triangle trigonometry examples.